Ladies and gentlemen, welcome back. This is the final tutorial for students who are in Algebra 1 Goal 6. Now our last little piece of probability and statistics that we're dealing with is specifically going to be probability and getting used to the fact that a lot of these are going to be DSA's questions. So odds in favor and against is a DSA question. Experimental is a DSA question. Let's see here. Objects that are not distinct is a DSA question. So it starts to you start to realize, oh wait, wow, these are probably topics that I need to know in earnest. So let's zoom in a little bit and get ourselves comfortable. The big thing to deal with probability of an event is that you're always going to have some kind of part over whole, and those are the key things that you're constantly looking for as we go through these particular topics. So since this is introduction, we're going to start on easy mode. We have 10 marbles, so that's our whole. There are 10 total, and then we can kind of see in the bag that they're all broken up into indistinct colors. We have a couple of blacks, a couple of grays, and a whole bunch of whites. So what is the probability that it is black or gray? So the question you're asking yourself is, how many black or gray are there? That's what you're asking yourself. So we have 1, 2, 3, 4, 5. 5 out of 10, and this simplifies to 1/2. All right, let's do one more, because this one also tries to trick you, this particular topic. 10 equally sized slices, all right. The dial is spun so that it stops on a slice at random. What is the probability that it stops on a gray slice? Question mark, question mark, question mark, question mark. Are there any gray slices here? No, it's 0 out of 10, so therefore it is not possible. I actually did not know that this was an option for this topic until when I was doing the screen grabs. This is new to me. I assume that means that it's rare when you're doing it on your own in the topic, but since I found it, I definitely wanted to make a screen grab and make sure you knew it. Next one, involving one die or choosing from distinct objects. This comes from a couple of different flavors, and these two here are the most common that you're going to see. You have balls labeled 1 through 11, so there's 11 total. So again, this is our whole, and now we got to figure out how much is our parts. One ball will be randomly picked. What is the probability of an odd number? So odd numbers are 1, 3, 5, 7, 9, and 11. So how many are there? 1, 2, 3, 4, 5, 6. 6 out of 11. That's going to be our answer. Then the next one contains 9 cards. The one thing they do nice to you, when I was originally looking at the screen grab, I thought I had to count out how many letters there are, but it outright tells you in the problem, generally speaking, there will be an exception, but generally speaking, they tell you what your whole is right there in the first sentence. One card is randomly chosen. What is the probability of choosing a letter from P to M? So 1, 2, 3, 4. There are 4 out of the 9 probabilities. And suddenly you start to realize that this actually isn't that bad. Now let's try to make it a little bit more interesting, tick it up a little bit. And this one I have a lot of questions from students on, so I'm going to go through the effort of going through actually more than just a couple of examples. So we have 7 white eggs and 14 brown eggs. They don't tell you the whole. Now we have to figure out what is our whole. What is 7 and 14? 21. Next we are told half of the brown eggs are cracked. That will be important. When an egg is randomly selected, what is the probability that it is a cracked brown egg? So here's what we're doing. If there are 14 brown eggs and then half of them are cracked, what is that going to be? 7, because 14 times 1/2 is 7, or 14 divided by 2, either or. So this is going to be 7 out of 21. And keep in mind, they always want simplest form, so they will nitpick you on this. 7 over 21 simplifies to 1/3. Let's do another example, make sure we're comfortable. We have 9, 6, and 5, so that's going to be out of 20 total. And then what is the probability that it is not a white shirt? So how many not white shirts are there? We have 9 black and 5 gray, so what's the total? 14. What does that simplify to? 7 over 10, or 0.7. All right, another one. Scroll over to the side here. An organization will give a prize to a local artist. They will be chosen among 6 painters, 2 sculptors, 9 photographers. So again, you're adding these up to find your whole. 6 and 2 is 8. 8 and 9 is 17. What is the probability that the artist chosen will be a painter or a sculptor? Painter and sculptor total add up to what? 8. 8 out of 17. Movie collection, and then is similar again. You have 7, 12, and 2, so that is going to be 14 and 7, which is 21 again. What is the probability that it is not an action movie? So we're going to cross out the 7. What are we left with? The 14, which again, simplest form, divide by 7, divide by 7, you're going to have 2/3. And you're starting to realize, okay, we're kind of doing the same thing over and over again. And then this is the biggest one. This is the biggest DSA question that hands down I get the most questions on. And this is a DSA topic. Here's what's going to happen, and I'm actually going to put this one on pause. I'm going to scroll over to the spinner because visually that's a little bit better. What's happening is you are looking for two things. You are looking for theoretical and you are looking for experimental. Those are dependent on different things. Theoretical is going to go to your spinner. Experimental is going to go to your table. That's what you're keeping an eye out for. And this one specifically, they want us to use decimals. Okay? So what are we looking for? Black or white? So 1, 2, 3, 4, 5, 6. 6 out of 10, which is going to be 0.6. So 0.600. They're going to want 3 decimal places for this. Next up, we are told that there are 40 trials. And how many are black or white? 14 plus 7 is 21 out of 40. And now let's pull out our calculator. So we are going to do 21 divided by 40. And what do we get? 0.525. 0.525. Now here's what they're expecting you to understand when you're looking at theoretical and experimental. They give you these bunch of options. So a large number of spins, difference should be small. Large number of spins, no difference. Large number of spins, large distance. What you are looking here, if you think about this, if you're spinning the spinner over and over and over and over again, if you spin it only once and you land on, say, a white, then you have a 100% chance of getting on white. If you spin it 2 times, then it becomes 50% of landing on white. And your percentages get smaller and smaller the more and more spins you have. The result of that was, when it's said and done, was that when you have a large number of spins, like here, when you had 40 spins here, you start to realize that it's getting a little bit closer. If there were 1,000 spins, it would be something like 5.89. If you had 10,000 spins, it might be 6.01. What's happening is that it's getting closer, which means it should be small. So what you're looking for is more trials and then closer numbers, some variation of what that's going to say. So with that as our walkthrough, let's go over to the other one because they don't give us a spinner for this one. What instead is we're told we have 25 trials. All right, so this is for experimental. So which one is experimental? That one's experimental. So it's going to be out of 25 trials, and then we're looking at 4 or 5. So how many times did we get a 4 or a 5? 6. So our answer here is going to be 0.240, I believe. Let's find out. So 6 divided by 25. Nope, that didn't work. 6 divided by 25. 0.24. Yay! Mr. Ball was smart. So then what's theoretical going to be? Well, how many total outcomes are there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be out of 10. And then how many are going to be a 4 or a 5? There are 2 out of those, which is 1/5, which is 0.2. So this would be 0.200. And again, there is how many trials for this? 25 trials. That's still pretty low for a number of trials. So we're kind of close, but we could get better. Imagine now instead if you had 10,000 trials, it would be way closer. It would be like 0.201 or 0.10, something like that. So again, we want more trials and we want small. So larger number of trials, small. That's the one we're looking for. So that's how you're going to be doing this one. Again, not at all subtle. This is one of the most annoying ones for DSA kids, and I have now hopefully made it easy for you. Next one, odds in favor, odds against. the words themselves kind of tell you what you're going to be doing. So if you're going to be doing odds in favor, it's going to be how many ways you can win to how many ways you can lose. If it's odds against, is going to be how many ways you can lose to how many ways you can win. You'll notice that there is no whole here. So you're not going to be adding these up. You're going to be figuring out how many wins, how many loses. So if we're looking for a large stuffed animal, and this is odds against, how many not large are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10, okay? How many large are there? 2. That's what they're looking for. Odds in favor of winning a large stuffed animal, that's the reverse. 2 out of 10, because there's 2 ways you can win, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ways that you can lose. All right? Give another example. Scroll to the side just a little bit. Not that much. All right, what is odds against? So it's going to be lose to win. And what are we winning? Let's see here. If it stops on a gray slice. So how many not gray slices are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. And how many gray slices are there? 1. All right, let's see here. What are the odds in favor? That's going to be your win to your lose, which is going to be 1 to 9. So this is the only topic in the software where it is not a part to a whole. So you've got to keep an eye out for that. And you can tell by the phrases odds against and odds in favor rather than just odds. One more. Outcomes of event probability. So this one is a little bit easier. You're just getting used to what it's actually asking. So you want a tail on the first toss or the second toss or both. Both. So does this meet that condition? Yes, it does. Is this on the tail first or second? Yes. Tail first or second? No. Tail first or second? No. Tail first or second? Yes. Tail first or second? Double yes. Tail first or second? Double yes. Tail first or second? Yes. So what did we end up having? Having 6 out of 8. Over here, alternating head or tail. So alternating no, alternating no, alternating no, alternating no, alternating yes, alternating no, alternating no, alternating yes. That's 2 out of 8. So this one visually is a little bit easier. 2 or more tails. 2 tails no, 2 tails yes. 2 tails no, 2 tails no, 2 tails no, 2 tails yes. 2 tails yes, 2 tails yes. How much is that? 1, 2, 3, 4. 4 out of 8 total. That's what you're looking for this. All right. Next up, suppose that 3 children are soon to be revealed, and we're looking at gender. So a boy in the last birth. Boy in the last, 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 boy in the last. So we have 4 out of 8 probabilities. 2 or more girls. 2, 2, 2, 2, 2, 2, 2 or more girls. How many do we have? 1, 2, 3, 4. 4 out of 8. Okay? Then, it's a terribly written form, Mr. Blanc. Bad form. Girls not, no girls in the first 2 births. So no girls, 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 no girls. 2 out of 8. So this one is actually one of the easier topics. And then the last topic of the day, probability of 2 dice rolls. This one actually, before you do anything, I like having my numbers set up first. 3, 4, 5, 6. Since there's 6 faces on your die, 1, 2, 3, 4, 5, 6. 2 faces on your die. Let's see here. We want a sum greater than 6. So sum is what we're looking for. So 1 plus 1 is 2, 3, 4, 5, 6, 7, 8. Or 8. Yeah, good job, Mr. Blanc. 3, 4, 5, 6, 7, 8. 3 and 1 is 4, 5, 6, 7, 8, 9. 4 and 1 is 5, 6, 7, 8, 9, 10. 5 and 1 is 6, 7, 8, 9, 10, 11. And then 7, 8, 9, 10, 11, 12. That's what we're looking for here. So what we want to do now is figure out sum greater than 6. So sum greater than 6 are all of these. So how many are there? There are 36 total. That's our whole. And how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. Those are both divisible by 3, so that's going to be 7 out of 12. So that's for the probability of event A. What is B? So let's see here. Let's erase this for a second, or at least get most of it off. Sum of being an odd number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 out of 36, which simplifies to 1/2. That's all you're doing for this, okay? So let's now instead take all of this little table, handy table, and move it over. So let's see, move this over. Move this over. Okay, we're all set. Now, what we're looking to do over here is to specifically sum greater than 9. So what is going to be our sum greater than 9? Again, it's out of 36. 1, 2, 3, 4, 5, 6. 6 out of 36, which simplifies to 1/6 for part A. Okay, next up, let's see here. We have odd number. We already figured that out. That's 18 out of 36, which ends up being 1/2 for probability B. So for this particular topic, again, you want to set your tables up first. I believe it's always a dice roll. Let's see here, 2 rolls of a dice. Yep, this is always going to be a dice roll. And so having this table set up in advance so you can do your counting actually makes life a little bit easier. And that, ladies and gentlemen, is everything for probability, which is the final family of topics in Algebra 1, Goal 6. You now have everything you need in order to be successful on the BSA. I humbly wish all of you good luck. As always, stay happy, stay healthy, stay safe. See you in the next one.